Connecting the common terminal of a 120-volt time clock to the ground in a 240-volt circuit is incorrect and unsafe. Doing so creates a short circuit between the two hot legs of the 240-volt supply. This can lead to excessive current flow, potentially damaging the time clock itself, the wiring, and the heater connected to the circuit. More importantly, it poses a significant electrical shock hazard. The correct procedure for installing the time clock involves running a dedicated neutral wire back to the electrical panel. This neutral wire provides a stable reference point for the time clock's 120-volt operation. The common terminal of the time clock should then be properly connected to this neutral wire. There are some additional safety considerations that you need to be aware of. Firstly, it is important to always follow the manufacturer's instructions when installing time clocks and other electrical devices. These instructions provide specific guidance on how to properly connect and operate the device safely. Secondly, ensure that all electrical connections are made properly and securely. Loose or poorly made connections can create resistance, leading to heat buildup and potential fire hazards. Thirdly, it is advisable to use a multimeter to verify that the circuit is wired correctly before energizing it. This helps to identify any potential wiring errors and prevent damage to the equipment or injury to personnel. Fourthly, have the circuit inspected by a qualified electrician before operating it. A qualified electrician can verify that the installation meets all applicable electrical codes and safety standards. Grounding refers to connecting an electrical circuit or equipment to the earth. This provides a low resistance path for fault currents to flow back to the source, helping to protect against electrical shock and prevent damage to equipment. A short circuit is an abnormal condition in an electrical circuit where current flows through an unintended path with very low resistance. This can cause a large amount of current to flow, potentially damaging equipment and creating a fire hazard. An electrical shock occurs when a person comes into contact with an energized electrical circuit. The severity of the shock depends on the voltage, current, and duration of contact. Electrical shocks can cause serious injury or even death. A neutral wire is a conductor that provides a return path for current in an alternating current circuit. It is typically connected to the neutral point of the power source, which is usually grounded. A multimeter is a versatile electronic instrument used to measure voltage, current, and resistance. It is an essential tool for electricians and other electrical professionals. Electrical codes are a set of regulations that specify the requirements for the safe installation and operation of electrical systems. These codes are typically developed by organizations such as the National Fire Protection Association and are enforced by local authorities. A qualified electrician is a person who has the necessary training, experience, and qualifications to safely install and maintain electrical systems. They are typically licensed by a state or local authority. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical safety. When dealing with electrical systems, it is always best to err on the side of caution. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Working with electricity can be dangerous if you're not careful. Here's a breakdown of key concepts for safety. Firstly, always turn off the power before working on any electrical circuit. Locate the circuit breaker or fuse that controls the circuit you'll be working on and switch it off. Use a voltage tester to confirm that the power is indeed off before touching any wires. Secondly, never work in wet conditions. Water conducts electricity, so working in wet conditions significantly increases the risk of electric shock. Make sure the area is dry and that you're not standing in any puddles. Thirdly, use insulated tools. Electrical tools should have insulated handles to protect you from electric shock. Check the insulation regularly for any cracks or damage. Fourthly, wear appropriate personal protective equipment. This includes safety glasses, gloves, and shoes with non-conductive soles. These items can help protect you from electric shock burns, and other injuries. Fifthly, understand the circuit you're working on. Before you start, take some time to understand how the circuit is wired and what each wire does. This will help you avoid making mistakes that could lead to electric shock or damage to equipment. Sixthly, never overload circuits. Overloading a circuit can cause the wires to overheat and start a fire. Make sure you know the amperage rating of the circuit and don't exceed it. Seventhly, use ground fault circuit interrupters, GFCIs. GFCIs are designed to protect you from electric shock by detecting ground faults. They should be used in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoors. Eighthly, respect electricity. Electricity is a powerful force that can be dangerous if not handled properly. Always treat electricity with respect and take the necessary precautions to protect yourself. Ninthly, if you're not sure, ask for help. If you are not comfortable working on an electrical circuit, or if you have any questions, don't hesitate to ask for help from a qualified electrician. It's always better to be safe than sorry. Tenthly, know your limits. Don't attempt electrical work that is beyond your skill level. Electrical work can be complex and dangerous, so it's important to know your limitations and only do what you're comfortable with. There are some things that should be remembered about the NEC when dealing with electrical work. Firstly, the National Electrical Code, or NEC, is a set of standards for safe electrical installation. It's updated every 3 years, so it's important to use the latest version. Secondly, the NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Thirdly, the NEC is not a law, but it is often adopted by state and local governments. This means that it has the force of law in many areas. Fourthly, the NEC is intended to protect people and property from electrical hazards. Following the NEC can help prevent fires, electric shocks, and other electrical-related accidents. Fifthly, the NEC is complex and can be difficult to understand. If you're not familiar with the NEC, it's best to consult with a qualified electrician. Sixthly, the NEC is not a substitute for good workmanship. Even if you follow the NEC, it's still important to do quality work. Poor workmanship can lead to electrical problems and hazards. Seventhly, the NEC is not a one-size-fits-all document. There may be local amendments to the NEC that you need to be aware of. Check with your local building department for more information. Eighthly, the NEC is constantly evolving. As new technologies and materials are developed, the NEC is updated to reflect these changes. Ninthly, the NEC is a valuable resource for anyone working with electricity. By understanding and following the NEC, you can help ensure that electrical installations are safe and reliable. Tenthly, always refer to the specific edition of the NEC that is adopted in your jurisdiction. Electrical codes vary from location to location. There are important things to remember about voltage, amperage, and resistance. Firstly, voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Voltage is what drives the current through a circuit. Secondly, amperage is the measure of electrical current flowing through a circuit. It is measured in amps. Amperage is the rate at which electric charge flows. Thirdly, resistance is the opposition to the flow of electrical current in a circuit. It is measured in ohms. Resistance limits the amount of current that can flow through a circuit. Fourthly, voltage, amperage, and resistance are related by Ohm's law. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Fifthly, voltage can be either alternating current, or AC, or direct current, or DC. AC voltage changes direction periodically, while DC voltage flows in one direction only. Sixthly, amperage can be either alternating current, or AC, or direct current, or DC. AC amperage changes direction periodically, while DC amperage flows in one direction only. Seventhly, resistance is the same for both AC and DC circuits. Eighthly, voltage, amperage, and resistance are all important factors in determining the safety and performance of an electrical circuit. Ninthly, understanding the relationship between voltage, amperage, and resistance is essential for anyone working with electricity. Tenthly, always use the multimeter to measure voltage, amperage, and resistance in a circuit. Be sure the time clock and the heater are compatible from a voltage point of view. This is not a matter of opinion, this is a matter of electrical safety.